Imagine a tornado, a swirling vortex of wind and debris, powerful enough to uproot trees and flatten buildings. These natural phenomena are both terrifying and fascinating, showcasing the raw power of nature on Earth. Now, picture it on the sun, a monstrous vortex of fiery plasma towering over Earth. These solar tornadoes are not just larger, but immensely more powerful, driven by forces beyond our planet's atmosphere. These are solar tornadoes, colossal whirlwinds of superheated gas, some reaching heights taller than our entire planet. Imagine a tornado so vast that it could engulf Earth several times over, a true giant in every sense. These fiery giants dance across the sun's surface, a testament to the awe-inspiring power of our nearest star. They twist and turn, driven by the intense heat and magnetic forces at play, creating a mesmerizing and dangerous spectacle. These aren't your typical terrestrial tornadoes. While Earth's tornadoes are formed by wind and weather patterns, solar tornadoes are born from the sun's magnetic fields and the extreme temperatures of its surface. Instead of swirling air and debris, they're composed of plasma, the fourth state of matter. Plasma is a hot ionized gas where electrons are free from their atomic nuclei, creating a sea of charged particles. In this state, electrons are stripped from atoms, creating a swirling sea of charged particles. This plasma behaves differently from the gases and liquids we're familiar with, responding strongly to magnetic and electric fields. This charged plasma, influenced by the sun's powerful magnetic fields, whips into a frenzy, forming the spectacular solar tornadoes we observe. These magnetic fields twist and turn, guiding the plasma into towering, spiraling structures that can last for hours or even days, showcasing the dynamic and ever-changing nature of our sun. Picture a pot of boiling water. The water at the bottom of the pot heats up, becomes less dense, and rises to the surface. As it reaches the cooler surface, it loses heat, becomes denser, and sinks back down. This continuous cycle creates a rolling motion known as convection. Bubbles rise, cool, and fall back down, creating a rolling convection current. This process is not just limited to a pot of boiling water. It happens on a much grander scale in the universe. The sun's surface behaves similarly. The sun, a massive ball of hot plasma, experiences convection currents on a colossal scale. Heat from the sun's core rises, cools, and sinks back down, generating powerful magnetic fields. These convection currents are responsible for transporting energy from the sun's core to its surface. These fields, like invisible ropes, twist and turn, dragging the plasma along with them. The sun's magnetic fields are incredibly complex and dynamic, constantly changing and interacting with the plasma. As these magnetic fields become increasingly tangled and energized, they erupt from the sun's surface, pulling vast amounts of plasma with them. These eruptions can release enormous amounts of energy, equivalent to billions of atomic bombs. This upward surge of plasma, guided by the twisting magnetic fields, forms the unmistakable funnel shape of a solar tornado. These solar tornadoes are also known as solar twisters or solar vortices. These fiery twisters can last for days or even weeks, spinning at speeds of up to 300,000 miles per hour. They are a testament to the incredible power and complexity of our sun, a star that continues to fascinate and inspire us. Solar tornadoes are more than just a visual spectacle. They play a significant role in space weather, the ever-changing conditions in space that can impact Earth. These swirling behemoths are often associated with solar flares and coronal mass ejections, powerful bursts of energy and charged particles that erupt from the sun. When these solar storms reach Earth, they can interact with our planet's magnetic field, causing geomagnetic storms. These storms can disrupt satellites, interfere with radio communications, and even trigger power outages. Understanding solar tornadoes and their connection to space weather is crucial for protecting our technology-dependent world. Throughout history, Earth has been bombarded by solar storms, leaving their mark on our planet and its inhabitants. In 1859, the Carrington event, the most powerful geomagnetic storm ever recorded, disrupted telegraph systems worldwide, causing sparks to fly from equipment and even starting fires. More recently, in 1989, a solar storm caused a major power outage in Quebec, Canada, leaving millions without electricity for hours. These events serve as stark reminders of the sun's immense power and the potential impact of space weather on our lives. Section 5. The Carrington Event, a solar storm for the ages. The Carrington Event stands as a stark reminder of the sun's raw power. This monumental solar storm, which occurred in 1859, is the most powerful geomagnetic storm on record. It serves as a vivid illustration of how interconnected our planet is with the activities of our star. In 1859, a massive solar flare erupted from the sun, unleashing a torrent of charged particles that slammed into Earth's atmosphere. This event was so intense that it caused widespread technological disruptions, even in an era when technology was relatively primitive. Telegraph systems went haywire, with operators reporting electric shocks and even fires. The electrical currents induced by the storm were so strong that telegraph paper caught fire, and some operators could even send messages without batteries, using only the auroral current. Auroras, typically confined to high latitudes, were observed as far south as Cuba and Hawaii. These spectacular light displays, usually seen near the poles, painted the skies in vibrant colors, mesmerizing people across the globe. The event, named after astronomer Richard Carrington, who witnessed the solar flare, highlighted the intimate connection between the sun and Earth and the potential for disruption from powerful solar storms. Carrington's observations were crucial in understanding solar activity and its impact on our planet. This event remains a benchmark for scientists studying space weather and its effects on modern technology. Section 6. Predicting the sun's mood swings. Scientists are constantly working to improve our ability to predict solar storms. By studying the sun's activity, including the behavior of solar tornadoes, they aim to give us advance warning of potentially disruptive space weather events. Just like meteorologists forecast weather on Earth, space weather forecasters use sophisticated models and observations to predict when and where solar storms might occur. This information is crucial for protecting our critical infrastructure and ensuring the safety of astronauts in space. Section 7. The Future of the Sun, a Dance of Destruction and Rebirth. The Sun is a dynamic star, constantly evolving over billions of years. While its eventual fate lies in becoming a red giant, engulfing the inner planets including Earth, its present activity continues to fascinate and challenge us. Solar tornadoes, with their awe-inspiring power and influence on space weather, remind us of the Sun's profound impact on our lives. As we continue to explore and understand our closest star, we unravel the secrets of its fiery dance and learn to live in harmony with its powerful rhythms. Section 8. A Cosmic Conversation. Your thoughts on our star. The Sun, our life-giving star, is a source of endless wonder and fascination. What are your thoughts on the Sun's fiery tornadoes and their impact on our world? Share your perspectives and join the cosmic conversation.